So small c is milliliters of solute over milliliters of solution times 100%. So if this is vinegar, the solute will be the volume of acetic acid in milliliters, and on the bottom it'll be milliliters of the container of vinegar. You have to record this is a small c and these in milliliters. Don't use liters. So you're going to have to do some converting. How many milliliters are in a liter? 1,000. So if you have a 2.5 liter jug of vinegar, it's 2,500 milliliters. If you have a weight by volume percent, then small c is equal to the grams of solute over the milliliters of solution. So if you're given kilograms, you have to convert to grams. So this could be for something where you have solids in a liquid or a semi-liquid state. And then the percent weight by weight. Small c is grams of solute, grams of solution times 100%. These are the only units you can use in these equations, so you might have to do some conversions given the data that you have. So we're going to do a couple of examples. What is the weight per weight concentration? So you're going to put W over W percent is equal to 40 grams of sodium hydroxide in 400 milliliters of water. So, which one is there in the smallest amount? The NaOH. So we're going to put 40 grams over 400 milliliters times 100%. So what's the percent? Hope you don't need a calculator. Oh, sorry, it's weight per weight. My mistake. 1 milliliter equals 1 gram, therefore 400 milliliters equals 400 grams. Sorry, thought I was doing the weight per volume. So what do you get? 10%. 10%.
I also have a question.
Yep.
Do we also have to write that, like 1 milliliter equals 1 gram?
Yes, you should always show a conversion. Some of you on your test just aren't showing enough work. You're skipping steps. This is considered work. So put any conversions, any assumptions in. Some of you did question 5 and didn't show any of your work for figuring out limiting reagent. You picked one of them because maybe you did it in your calculator, but you didn't write it down. You don't write it down, you don't get credit. Okay, so this is example number 1. Example number 2. How much acetic acid is dissolved in water if 2.5 liters of a 5% vinegar solution? So this is a volume per volume percent. So this is milliliters of solute over milliliters of solution times 100%. Plug in what you do know. You've got 5% solution. We want to figure out the milliliters of acetic acid. We know we've got 2.5 liters, so we've got 2,500 milliliters times 100%. We want to isolate milliliters of solute, so any numbers on that side, we're going to move to the other side and do the opposite math. So we have 5%. We're going to multiply it by 2,500 milliliters, and we're going to divide it by 100%. So how much acetic acid has to be added to 2.5 liters to make this solution? 125? So this is typical acetic acid, like white vinegar that you have, 5%. Sometimes it's 3%. You can buy 10%, and that's called cleaning vinegar. It's good if you want to be environmentally friendly, cleaning your bathroom.
It'd be 1.2 times 10 squared for sig figs.
For significant digits, we would have to have 2 sig figs. Yeah. Yeah, exactly. That's what you're doing. Yeah. We actually buy it 30% or 6%. I've used 30% before and not used gloves to dilute it, and I've had it on my fingers. And it doesn't feel nice. So those are household products. Chemists use molar concentration. So we're going to be talking about concentrations for probably the next 2 or 3 weeks. So if you're not paying attention, you want to start. So molar concentration. For a chemist, this is the most common method of expressing concentration. It's one we can use because if I know my molar concentration that I need to make, like I have to make for your practical exam, if I know the concentration that I need, I can work backwards, figure out the mass I have to dissolve. So molar concentration. In university, you may have an older professor that calls this molarity. And that is the exact same thing. We call it molar concentration now. We used to call it molarity. It's just a different way to say the same thing. Covalent molecular, molarity, molar concentration. It is the same thing, except if I have a concentration that's 1.0 moles per liter in the new way, old way, it's that 1.0 capital M, where M means molar, which is short for molarity. So you're gonna, if you take chemistry in university and you've got some old person or older person teaching you, by older I mean older than 30, 40. They're going to use molar. Okay, what is the concentration of a solution that contains 16 grams of sodium chloride in 200 milliliters of solution? We have 16 grams of sodium chloride. We have 200 milliliters of solution. We want moles per liter, so I'll do formulas, then we'll do dimensional analysis.
Find moles of sodium chloride.
Find moles of sodium chloride. We've got grams. That's mass. So we have the chemical formula. So we can find molar mass to calculate moles. So 16 divided by 58.44 is? So now we can plug this into the formula. C equals N over V, 0.273785 divided by, can I stick 200 milliliters underneath? Got to convert it to liters. And your answer is? Say that again, please.
1.37 moles a liter.
Let's pretend that 200 milliliters has a period after it. Put a period, a decimal place after the 200, so that it has 3 sig figs. So there's your concentration. 2 steps. So we have the molar mass, the mass, and the volume to work with. Same 3 pieces of information. We need moles on top. There is 1 mole of sodium chloride for every 58.44 grams of sodium chloride. Got to get rid of grams. So if I multiply that by 16 grams, disappears. I still need liters, so multiply it by 1 over 0.2 liters. You end up with moles per liter. What is the number of moles needed to make 200 milliliters, 200 milliliters of a solution with a concentration of 0.1 mole per liter? So this is the sort of way I use this more, is I figure out the mass that I need. So C equals N over V. So how do you find moles, given that that's your formula? Yovam?
So it would be C times V equals that.
Yeah, C times V. 0.1 mole per liter times 0.2 liters. Dimensional analysis. It's the same thing. So how many moles do you need?
0.02.
Yeah, 0.02. What is the concentration of O2 in ppm? Which one of these three ratios do you think we're going to use? We've got a 250 milliliter sample of water and 2.2 milligrams. Yeah, we're going to use milligram over liter. So we have 2.2 milligrams. And we have 0.25 liters. What is that number? Drew?
So you have the ppm?
Yep.
By 8.8 ppm.
So the units are interchangeable. If you've got milligrams over liters, you can say that that's ppm. Okay? We need to keep track of the oxygen in the water, because if it drops too low, your fish will start dying. Is the same thing as 300 milligrams per liter. You have 4 liters. So if you multiply that by 4 liters, you get your milligrams.